Global Head of Infrastructure at ADP. A 26-year veteran within the world of technology, spanning from programming to infrastructure, Mark is responsible for ADP's global infrastructure, which supports the company's global hosting business and millions of end users. He provides global leadership and vision for infrastructure and platform architecture. In addition, he is responsible for developing a global infrastructure strategy to align ADP's architecture across the enterprise. Prior to joining ADP in 2016, Mark was the global head of infrastructure at Bloomberg, where his focus was on servers, storage, databases, virtualization, procurement, and infrastructure workflow globally, along with the management of the global infrastructure budget. Today, Mark will discuss how data gravity could impact your cloud strategy. The need for companies to move their customer-facing products from private clouds and data centers to the public cloud has become increasingly apparent in 2020. Enterprises are developing living technology that is more cloud-native, making their data much more accessible and scalable. However, as companies across the globe begin embracing this transition, they are facing ramifications after the shift in technology takes place. Ultimately, the demand is affecting enterprise cloud infrastructure and how organizations are developing new technology to support the growing move to public cloud, the biggest challenge being data gravity. Mark, the floor is yours.
Hello, my name is Mark Chamberlain. I'm the Global Head of Infrastructure at ADP. I hope this is coming through clearly and you can hear me as well as you can see the screen share that I have. For many of you, you're coming back after a long weekend, and this might be the first time you're jumping into technology, so thank you for taking the time to participate in our topic today. We're going to be talking about how data gravity can impact your cloud strategy and the journey to the public cloud. Many of you on the phone and listening in could be already in the public cloud or trying to think about how to get there. What are the things that you need to consider? What are the things you need to think about as you're trying to figure out your strategy of moving to the public cloud? One of the things you don't typically think about is that data has gravity. And we're going to jump into and talk about what does that mean? What does data gravity mean? How does that impact your cloud strategy? And really some guiding principles around how to think about going to the public cloud. There's a lot of information out there, but sometimes just finding that first step, trying to figure out how to approach it sometimes is the hardest. But once you start, it gets easier and easier after that. Before we jump into our topic, let's talk a little bit about ADP. You can see a lot of numbers on this screen. And many of you on the phone probably think of ADP as a payroll company. You've either heard of us as a payroll company or you actually get checks or have checks that have the ADP logo on them. But we actually do a lot more than that. We do everything from recruitment to retirement and everything in between. We have over 810,000 clients worldwide and over 58,000 ADP associates globally supporting our customers in over 140 countries. We move over 2.1 trillion US dollars for our clients, and we support over 40 million workers worldwide as far as getting paid. We've been doing that for over 70 years. So we've been around for a long time, and we've been using technology for a long time to solve the needs of our customers, and it's much more than just payroll. So let's talk a little bit about that innovation. Let's talk about that journey that ADP has been on. So back in 1949, Henry Taub launched ADP, Automatic Payroll Incorporated. In 1962, ADP released the first IBM computer for payroll. And you can see there's a lot of firsts on this screen. The next one's interesting and relates to our topic. We had a product called EasyPayNet, and that was the first cloud-based payroll solution. And again, that was in 1998. If you look at the time around AWS launching, which is probably considered the first public cloud provider, that was around 2006. So ADP in 1998 started providing cloud solutions for their payroll for their customers almost 8 years before that. And in 2000, we were actually launched GlobalView, which is our first global cloud HCM solution. So we've been doing cloud and using technology for quite some time to meet the needs of our customers, and we've been doing it in a cloud-based approach. A couple other things on the screen we'll touch on. ADP Mobile was the first HCM mobile application, and Data Cloud was the first HCM big data platform. So again, there's a lot of firsts on the screen, and ADP has a history of continually innovating and looking at new ways to meet the needs of our customers. Let's talk a little bit about the trends in technology. So the screen's really divided into two parts. The left-hand side is the software, and the right-hand side is really around all the infrastructure necessary to support that software. So going back to the software side, the first one, the number of software applications deployed by large firms worldwide has increased by 68% over the past 4 years. So there's a lot of software being written and deployed by large companies over the past 4 years. And you could probably say a lot of that has to do with the digital transformation that's happening. There's a lot of companies that are looking at how to go through and transform digitally in order to pivot and change to meet the needs of their customers. Next bullet, global spending on enterprise software is expected to grow nearly 9% this year. A lot of that's driven by cloud-based subscriptions. So there's a lot of software being used out there, and there's a lot more to be deployed. And all that has to run somewhere. And that goes to the right side. So you can see that there's three categories here. There's the traditional non-cloud, so physical servers out there supporting monolithic applications. You've got private clouds, and you got public clouds. So if you look at the diagram, you can see that the traditional non-cloud physical servers, monolithic applications, there really isn't a whole lot of growth there. It's relatively flat. But what you can see is that the use in the build out of private cloud as well as public cloud is increasing. And both of them are increasing quite a bit. So you can see that the focus is really going towards this cloud-based approach, these cloud-based solutions that meet the needs of your customers, and then having software that understands that. So let's talk a little bit about the ADP cloud transformation and the journey we've taken. Like I said before, we were out in the cloud before there was a public cloud. We were about 8 years in the cloud and providing cloud solutions before the public cloud came about. But the public cloud enables a lot of features and a lot of interesting things, and we are a consumer of the public cloud as well. Our next-gen products that we were building for the future of our customers were built cloud native and are cloud ready. So our future greenfield applications are being built on the public cloud. So it enables our future products, but it also enables us more flexibility. You always hear the statement that with a credit card, you could spin up infrastructure in minutes, and you can do that on AWS, right? Go to their portal, pick an EC2 instance. A couple minutes later, you spun up an IP addressable piece of infrastructure that you could deploy code on. So there's a ton of flexibility there. If you think about all the different services that are being offered by the cloud providers, there's a lot of solutions out there that will help you pivot the way you're building applications and allow you to do things that you never thought were possible before, and provide insights that your customers probably never even thought they needed. And there's a ton of transparency by using the public cloud. Everything from how is it being used to how are you responding to the needs of your customer to being able to provide transparency, leveraging new services that might provide insights that your customers never thought they needed or never had. So there's a lot of enablement possible by using the public cloud just based on the amount of things that are being offered from a services perspective, the flexibility that's out there, and the transparency as well. One of the things that the public cloud has offered us is that it's helped us pivot to what we're doing inside our private cloud, our private in our data centers. Being able to spin up infrastructure as quickly as you can on AWS has helped my team respond to being able to do similar. So when it comes to your private cloud solutions, making sure that you can respond in a way that your end users expect. So all of the developers at ADP expect to be able to spin up infrastructure just the way you can on AWS. That's helped my team respond to do similar, so we can respond as well to be able to spin up infrastructure just as fast. So it's not only enabling you to be able to do things in the public cloud in new ways, but it's also a good way to be able to look at how to do things differently inside your own private cloud as well. So how did we go about our cloud transformation? Like I said, we looked at products, our future products, and said, we're going to build those cloud native and cloud ready. So let's put those aside. Then we got all those brownfield applications, those applications that have been up and running and supporting your customer needs. How do you go about looking at those? How do you go about figuring out what your cloud strategy is going to be? Well, what do? We start small. And if you start small, you reduce the risk, you reduce the issues. Um, think of an application, maybe that's an internal application, maybe not used a lot, or it's used, but you have a team that's using it that's supportive of trying new things. Maybe that's a good prospect or a good application to be able to move to the public cloud. Maybe you think about your software development lifecycle, your development environment. Maybe that's a good place to start. Maybe you have a team of developers or a group of developers that are always trying new things, that are always looking to innovate. Maybe they're a good team to start with, and you actually move their development process out to the public cloud, and you have them start using that instead. And there's a lot of benefit to starting with your development environment. One is that you probably have infrastructure in your data centers now that you're using for that. Well, if you actually use the public cloud for your development environment, you could probably respond to the needs of your developers quicker because if you onboard or you bring into your company new developers, well, if you don't have enough capacity, you have to go out and buy it. Well, in the public cloud, you could just spin it up. Also, developers are usually not working 24/7, 365. So that means that there's a great opportunity to spin down that infrastructure when it's not being used. So nights and weekends might be a perfect time to go and spin down the infrastructure that's part of your development environment that will actually help you save costs as well. The next part of the framework, the guiding framework that we used, is be okay with failing fast. Um, One of the things that happens as you're experimenting and using the public cloud is that not only looking to put application out, we talked about putting smaller applications out, but you also have the ability to fail fast, and it's okay to fail, right? I think there's this perception that failing is not necessarily a good thing. It all depends on how you fail. If you fail fast, you learn from that failure, you grow with that and make sure it doesn't happen in the future, then failing isn't okay as long as you learn from it. If you're failing all the time, that's probably a negative. But being okay with failing fast is a good thing. And if you're practicing agile and you're doing 2 week sprints and you're building teams and a culture that way, failing is part of it. You know, you're sprinting fast. You want to see what the results are from your customer, and if those aren't meeting the needs, you're not waiting a year to figure out what did the customer ask for and did I develop what the customer actually wanted. You're actually finding out pretty quickly, and if it didn't meet their needs, you failed fast and you were able to respond to it quickly and then get something back to them quickly so to see if that actually meets their needs or not. The next part is being able to experiment with available technology. With all the services being provided by the public cloud providers, one of the things is to be flexible and to be able to spin things up quickly. The other part is also to being able to go and try new technology, try new services. If you need to be open to doing that, because if you are, there's a good chance that you're going to pivot your approach to solving one of your customer needs. You're going to apply technology that you never had before and might be providing solutions that you never thought were possible in providing solutions that your customer never thought were possible. So be open to experimenting with available technology. The last part is that large corporations, small corporations, whoever you are, you have your enterprise standards. You need to bring those to the public cloud. All of those processes, whether they're operational, whatever procedures that you have in place, you need to look at all of those and figure out what are those standards that you developed over the years that make your product unique, that help you support your customer the correct way. You need to bring those enterprise standards with you to the public cloud. There's going to be things that Amazon will help you with and are responsible for when it comes to standards and service level agreements. But then there's going to be the things that you need to bring forward as well that you've developed over the years that are unique to your company and are unique to your product to help you support your customer in your own unique way. So, our cloud transformation, these are some of the things that we thought about as we started pivoting and making decisions on how we were going to approach our cloud transformation and our public cloud journey, and some of the things that I thought were very beneficial along the way. So let's dive into some of the considerations and talk about some of these. So now that you've figured out the application that you've decided you want to move and you're willing to fail fast and you want to go out there and experiment with new technology, the first thing companies usually do is say, okay, I've picked my application, I'm going to pick it up and I'm going to lift and shift or forklift move it and move it into the public cloud. And that's okay, you can do that. That's going to get you into the public cloud quickly. You're going to be able to understand the benefits of the public cloud. You're just not going to necessarily get to use all the services that the public cloud provides. And you can see here that lift and shift doesn't scale. There's a lot of times that application that you lifted and shifted was a monolithic application that was built to run on an infrastructure that never failed. So if the infrastructure was never failing, you're never putting use cases into your code that would allow you to respond to infrastructure failing. When you go to the public cloud, you're actually building the opposite way. You're actually building to respond to needs, to be able to, if there is a failure, to be able to handle that failure and continue the application, continue it, allowing it to run, and your customer never knows. Being able to auto scale. If your application doesn't know how to handle adding more infrastructure to meet the needs of your customer, then you're not going to be able to leverage the benefits of auto scaling up or auto scaling down, being able to take away that infrastructure when there's no longer the demand. And those are features that if you take a lift and shift approach, again, depends on your application, might not work when you go to the public cloud. Let's say you take an application that was built a long time ago. Monolithic application built on infrastructure that's expected to be up for a long time. And you lift and shift that, that's okay. But now how do you go and start leveraging all of that feature and functionality that's available to you? Well, you need to start breaking down that monolithic application, breaking down that application into microservices. So start thinking about all the things that application does, and are there opportunities for you to break parts of it out and rewrite that code in a microservices way? The benefit of doing that is you no longer have this monolithic application. You can deploy now your microservices at different speeds. You don't have to move this one application that you have to do a significant amount of testing on because it's so complex. You can actually, by decoupling this monolithic application into microservices, now deploy parts of them at different rates, at different speeds. It also allows you to go and respond to your customer needs at different rates and different speeds as well. So let's say you took this monolithic application and you broke it down into many microservices, but let's say one of those microservices is a computational complex process. Maybe that takes more infrastructure to meet the needs of the customers. And as your customer needs grow and you're spinning up more, you can spin that more of that up without necessarily have to spin up other parts of your application. So maybe the front end part of it doesn't need to spin up as much because it's very efficient. But this complex calculation, because it's so complex and it needs so much compute to perform, you can scale that differently. So microservices give you a lot of benefits, not only from the release perspective, but also from the scaling perspective. From microservices, you could go to containers, but you could also go to something that's very popular now, which is a serverless architecture. Being able to use things like AWS Lambda, being able to go and spin up infrastructure, but doing it just based on the code that you need to run. So what you're really doing is you're actually just running the code that you need to run, and you're not worrying about the infrastructure underneath it. When you go to the public cloud and you use something like an EC2 instance, you still have to patch. And if you still have to patch, you still have to support that infrastructure. Again, there's a benefit to moving to the public cloud because you get to be able to go and use a lot of this feature and functionality, but you still have to make sure that from a security posture perspective and from a compliance perspective, resiliency perspective, and stability perspective, that you're still maintaining your infrastructure, so you still have to patch. But with serverless, all you're really doing at that point is running code. You're running your code when you need to run it, as much as you need to run it. And when you're not running it, it's gone. So serverless is really a new frontier in an area, in a direction a lot of companies are going. And then choosing the right application, right? Do you have that application, even if you decide to lift and shift it out to the public cloud, that it can be broken down in some way, whether it's into microservices, smaller services that are on EC2 instances, or can you start leveraging containers, do something like an EKS, using Kubernetes, or can you actually go all the way and start going to a serverless architecture where you're just running your code when you need to run it? And does the application you're moving allow you to do that? So again, going back to picking that right application based on the size, based on how it's built, and based on your approach. But now let's start talking about the data side of it. So we talked about the we talked about ADP and we talked about our journey. We've been in the cloud for a while, especially in our private cloud. Talked about our journey to the public cloud and some of the considerations we thought about in our approaches. One of the things that a lot of companies need to start doing too is thinking about data in this concept that data has gravity. And what do I mean by that? So all your data is in right now. Let's say you haven't moved to the public cloud. All of that data right now is sitting in your private cloud, your private data center. All your applications are there as well. And interacting with that data is relatively easily, right? You understand your network, you understand the network hops. How do you get to that data? How does your application respond to it? The latency is very small. But as you start thinking about moving your application out to the public cloud, you have to start thinking about that data as having gravity and your application being attracted to that gravity and to that data for it to be able to meet the needs of your customer. So the closer you get your application to the data, the better it's going to perform, the better user experience. So that's what I mean by data having gravity. But being at the center of your application, if you need to stay close to it, and the closer you are to it, the better your application is going to perform. That's good to know. But what happens as you move to the public cloud, you decide to decouple your application from the data and just move that application to the public cloud? What does that mean? You should start understanding where your private cloud is, where your data center sits, where your public cloud provider sits, and what's the latency between the two of those? What's the distance between the two of those? Because if you decide, let's move the application away from the data, well, you then need to understand how much is your application talking to that data? How many times is it making a call to get data and waiting for a response back with data to be able to meet the needs of your application? How many times does it need to do that round trip communication to get all the data necessary to be able to display the data or display the needs of your application so your customer has what they need? Well, all of that round trip communication, asking for data, getting that data back, the farther your data is from your application, the farther that data is from the public cloud, the longer that latency is going to be, the less performant your application is going to be, the more impact it's going to have to your end user. Let's say you take another approach and say, okay, I'm going to move all my data to the public cloud. But a lot of times, all this data that you have that's being used by your application is probably being used by other applications as well. At ADP, data is our middle name. We have a lot of data. And we have a lot of our products are using that data. They share that data. Well, if you move data with your application to the public cloud, what does that mean for the applications that are still left in your private data center, that are still part of your private cloud? Do they need to now call out to your data that you moved to the public cloud and pull that data back? And then there's this egress part that you need to consider, because when it comes to public cloud providers, that egress is a cost. There's a financial impact of doing that. So, moving your data to the public cloud, you can move it out there for free, but moving it back, that's where you have to start thinking about what is that? How much data do you now need to move back for those applications that stayed behind? And maybe the application that you pick is small and you can move the whole data set with you. That's great. That will allow you to continue to think about, how do I manage that data? All of this bundles together. It makes for a much simpler application move. It helps you get comfortable with public cloud quicker. But as you start working on more complex applications that have many more data sources, a lot more data, that require a lot more data to be used in order to meet the needs of your customer, you need to start thinking about that data gravity. Where is that data going to live? Is it going to stay back? If so, what does that mean for your application that just moved to the public cloud? If it's not going to stay back and it's going to move with you, what does it mean for those applications that are now sitting back in your private cloud or your private data center? And what happens to those? Maybe you are going to replicate that data. Maybe you're going to make a copy of that data. If you're going to make a copy of that data and move that to the public cloud, how do you keep it in sync? Again, you're trying to take this data gravity and make sure that your application stays as close to it as possible, so the latency that you're observing is as small as possible as well, so you're getting the performance necessary. So how does data gravity play a role? Well, can your data move to the public cloud? We talked about that. If it can, then all of a sudden that data gravity is still, it's important and your application is close to it. If it needs to stay in your data center, what's that latency between the new application location and your data center? Is this data in a database or is it in multiple databases? And how does that impact it? If you're going to move this data that's causing the gravity for your application, if you're going to move that to the public cloud, are you going to replatform it? Amazon, for example, has over 8 different database types based on the type of data you're looking to store. So are you going to replatform it? And if so, how does that change your data gravity? Does that change the way you approach writing your application? So going back to be open to experimenting with new technology when you move to the public cloud. You might want to re-platform it because you were having your data in a traditional database while it was in your private data center or your private cloud. When you move to the public cloud and you decide, okay, that data gravity is requiring me to move that data with my application to the public cloud, maybe that's a good time to re-platform it. Maybe it's a good opportunity now to use maybe a NoSQL type database. Maybe this is a big data application. You want to do something different with that as well. So is that data in a database? If so, what type of database? And do you need to re-platform it? And do you want to re-platform it? And if you do, is it going to change the way you approached the way your application was written in the past? Are you going to change the way you approach uh, your application and what it's doing to support your customer? And are you going to be able to provide potentially a new workflow or new insights to your customer in your application that they never had before? So being open to experimenting based on your data and based on the data gravity and your approach to what you're going to do with that. And do all the database features exist in the public cloud solutions you're looking into? So for example, a lot of large companies use a lot of traditional relational databases. One of those, for example, is Oracle. Great relational database product. A lot of companies are using it. Do all the features that you're looking to leverage in your Oracle database that's installed in your private data center or in your private cloud, do those features exist when you go to the public cloud? An example of something you want to think about is Oracle RAC. A lot of companies use Oracle RAC for a lot of reasons. You can scale and get a lot of good performance in its sharing data. The concept of an Oracle RAC databases is that it's got a shared data set that multiple databases across multiple servers are using. Well, that concept of sharing isn't popular when it goes to the public cloud. It's really a shared nothing architecture. And there is an exception. If you were to go to the Oracle, or go to Oracle's cloud, being that Oracle databases are part of the Oracle Corporation, you can actually run Oracle RAC on the Oracle Cloud. But if you look at something like an AWS or a Google Cloud, for example, those they don't do a lot when it comes to sharing, especially when it comes to features like an Oracle RAC database, right? You can run Oracle there, you just can't run the RAC feature. So what database features are you currently leveraging? If all your data is sitting in databases, and do those features exist in the public cloud? And if they don't, is that yet another reason to look into replatforming it towards another solution that might work better to help you manage that data? And again, this all goes back to that data gravity. What is the data doing? How is it being used? How is it that your application is leveraging that data? And by going to the public cloud, are you going to replatform your data and put it into a different database package and leverage new technology? Are you going to rewrite now your application? And is that the time to go and actually start thinking about, do I break that application down into the microservices? Do I start going in and then being able to scale up horizontally using auto scaling to meet the needs of your customer? Do I take that next step with containers? Or do I take that even further step around having a serverless application? So you start thinking about how your approach is going with your application. What application are you going to do this public cloud transformation with? And then what is the data behind it? And am I going to take that data with me? So is moving your data always the right move? Well, if you decide to move your data, that data gravity part of it, you need to bring that data with you, and you've decided that there's applications that are staying behind that don't need it. Okay, now you say, okay, I'm going to replatform it, or I'm not. I'm going to use the traditional or relational database product that you've been using. Now you have to start thinking about sometimes other parts of that data. Does your data contain PII information? Does it contain personally identifiable information? And if it does, Are you going to be masking that? Are you using masking features now inside your private data center, inside your private cloud? How do you protect that personally identifiable information? What happens with your data at rest? Are you encrypting it? Are you encrypting that data in motion? So now that you've made the decision to pull your data out of your private data center where you have these features, how do you do those now in the public cloud? And there's technology for all of it, but there's things that you need to consider as this data gravity continues to play a role in your determination on what products you're moving and how you're going to move them and what you're going to now do with that data from a data at rest perspective and what technology to how are you going to now change your application to what is that. Now let's look at that data itself and what are the things that you need to be thinking about as you're moving that data now. What kind of data is it? What are you going to do with that data at rest or that data in motion? And also the next item, who's going to be supporting that data in that database now? A lot of times with a traditional setup inside of large organizations, there's a centralized group or there's database administrators or database engineers that are there that understand the complex database technology. They understand the schema of the database. They understand how to manipulate a very sophisticated piece of software that's there managing all of this data. Does that change when you move now that you've made a decision with data gravity that you need to move that data? Are you going to now change your model? If you're going towards the DevOps model, maybe you do. Maybe you're thinking that, you know what, I'm going to use a piece of technology such as RDS, Relational Database Service from AWS, that takes care of a lot of features and functionality for you. When it comes to setting up an HANDR solution, when it comes to replicating across availability zones or across regions, you get the added management service going to the public cloud that you didn't necessarily have. You actually had a team of database engineers that knew that software intimately. Maybe you don't need them anymore. Or maybe your approach is that you're going to use a relational database service, but you still have the DBAs, those database administrators or database engineers there to help you make sure that that transition works and that you've got ongoing support. But then what happens with that model when it comes to compliancy, right? Or for auditing? When you go out to the public cloud, and we talked about bringing your enterprise standards with you. Well, when it comes to the, if you're ISO 9000, 9001, 27000, if you've got specific compliance requirements that you need to meet and that you're being audited at some kind of frequency, who is then going to be the one that's representing those audit findings? Is it your DevOps team or is it your traditional database engineering team? Who's going to be the one that's going to be making sure that the backups are happening? And they're happening at the frequency necessary. Are you doing full backups or incremental backups? When was the last time that you did a test restore to make sure that the data was actually recoverable in the event that something went sideways, whether you deleted data you didn't intend, you dropped a table, you dropped some data you didn't intend, or there's an issue that you lost the database, or there's a problem in an availability zone. So a lot of these considerations need to be thought through as, again, you start thinking about what is my approach to data? Where's my data going to live when it comes to this data gravity? And am I moving it? And if I move it, do I not only change the database technology, the software that I'm building and how I build it, but are you going to change the support model as well? And again, we talked about do the public cloud features, the public cloud solutions support the database features we talked about. When it comes to backups, are you going to, if you're using Oracle again, are you going to be using RMAN? Are you going to be backing up to something local from a disk perspective? Are you going to be backing up to an object store and using something like Glacier, where it's like a very infrequently used backup? So you could change and think about your cost differently. So again, things to think about as that data gravity starts playing a bigger and bigger role in your decision-making process. What are those things that you need to think about as that data gravity starts helping you make decisions based on not only the product you're going to move to the public cloud, but are you going to move just the front end and leave the database behind? Are you going to move the database with you? If you do that, what does that mean for that data? And how does that data support change? Does it change? And if it does change, what does that mean for your compliancy and audit requirements? So again, that data gravity starts as you peel back this onion, it starts having you think differently about your application, but it also helps you start thinking differently about what you're going to do with that data, how you're going to support that data, are you going to replatform that data to use new technology, and who's going to be the one supporting it, and what does that mean for the different compliancy and audit requirements you have out there. So I hope you found this useful. A lot of times as an organization goes down the path to think about where you're going from a cloud perspective and how to start that journey, going to the cloud is complicated, but then not thinking through things like, okay, what does it mean for my data, and where does that data live, and how am I going to get to that data, and do I bring that data with me, and what do I now need to do differently with that data in the public cloud, are things that you need to think about as you take this cloud journey. I'll be available later for questions, and hopefully you found this useful. Thank you again for taking the time. I hope that your cloud journey is successful, and you continue to think differently about the services that are available, and that you can respond to your customer needs using this new public cloud technology. Thank you very much.
Thank you, Mark. The idea of data gravity is a very interesting paradigm as we are looking at cloud platforms for analytical solutions. It does introduce a new concept that isn't so applicable, or isn't as applicable in the custom app dev space as it is in BI and analytics. And the reason why is because it's much more likely that we will be running a commercial application, at least as one piece of our stack in an analytical platform, and that is probably going to mean that we will be leveraging multi-cloud whether we like it or not. We might be leveraging, for example, like Power BI, which would be running in Azure, and maybe we're running some of our other data pipeline components in Google Cloud or AWS or something like that. And so as a result, we are going to have to take data gravity a lot more seriously, perhaps, than one might in a custom application space. Also, the sheer size of the data will make it likely that it will make much more architectural sense to leave the data on one cloud provider versus replicating across multiples, thus introducing perhaps more issues in relation to data latency between cloud providers. So this is why the idea of data gravity is such an important consideration whenever we start looking at cloud infrastructure providers. We will be taking questions from Mark over in the speaker Q&A area, and we'll see Mark over there. Thank you, Mark.